everyone, and welcome to this episode of the AWS for Games Boss Level podcast, where we seek to simplify and demystify how to most effectively use AWS technologies and offerings. My name is Chris Melissinos, and I'm the Principal Evangelist for video games here at AWS. And on today's program, we have Senior Solutions Architects, Adam Hatfield. Hey, Adam.
Hey, everybody.
JP Velasco. JP.
Hey, everyone. Daniel
Lee.
Hey, pleasure to be here.
And Associate Solutions Architect, Zach Sterling. Zach?
Hey, everyone.
All right.
Yeah, happy to be here.
We're glad to have you guys joining in. We're so glad to go ahead and kind of light the podcast back up again for 2025. There's a whole lot more coming for this year, but this is the first episode for 2025. And on this episode of Boss Level, we are continuing our discussion from episode 7, which was managing game lifecycle costs using containers, by exploring how to optimize container usage and best practices for that same lifecycle. But first, as we always do, let's talk about what we've been playing. So why don't we start right there at the top with Adam. Adam, what are you playing?
Oh, I started playing the Oblivion remaster.
Mm-hmm.
It's so good.
Now, is it a remaster or is it a complete, or is it a remake, right? So there was some discussion online that, well, it's more than just, texture packs and everything else. Like, do you find it to be different?
So it's like same overall like feel of like Xbox 360 Oblivion, which is what I really like. But it does seem like a lot of the systems have been kind of spruced up, and then like landscaping, environments, lighting, like it's all different and so much better. Like way more like immersive experience.
Nice.
Right now. So I'm gonna put 10,000 hours in this game probably.
Yeah, we also noticed, and we talked about this before we started recording, you also have unbuilt Legos, and as you said, some unfinished Warhammer miniature stuff behind you, right? So
yeah, also playing the life of being a dad. So time is limited on projects right now.
The greatest adventure, and there are no cheat codes, and there's no real, manuals or guidelines for it, right? So definitely a grand adventure. Well, awesome. All right, JP, how about you? What are you playing?
Yeah, I'm playing Tom Clancy Ghost Recon Wildlands.
Oh, have you played a lot of the Tom Clancy games before?
I play some. I think this is the second one, like open world. So essentially, there's some strategy to it. You got to hide in a very expansive world. You can do helicopters, boats. You can do vehicles, and you can play with friends too, which I do, and it's just fun. So
awesome, and that is the best, right? When you can play with friends that you care about. So that's great, excellent. Daniel, how about you, buddy? What are you playing?
Yeah, I've been going back to my roots, my own childhood, playing old school RuneScape. So MMO classic. It's been around for so long. But yeah, now really enjoying that.
Playing old school RuneScape. Of course, you saw the new version they went ahead and released, and that old school RuneScape goes all the way back to when I was at Sun Microsystems working on Java for game development back in the late 90s and then into the early 2000s forward. So anytime I see somebody fire up old school RuneScape, I'm like, yes, that's right, Java. That's right. That's how we do it.
Classic Java game. And I am really excited about that new release, the Dragon Wilds game. It seems to be built on Unreal and really beautiful, honestly. So I'm looking forward to trying that game at some point too.
Yeah, amazing. One of the best long tail greenfield kind of games, right, that we have in the industry. Yeah, that's awesome. Excellent. And Zach, how about you, buddy? What are you playing?
Yeah, I'm really excited for the announcement of Hollow Knight Silksong possibly coming out this year. And so I've gone back to playing Hollow Knight and for the hype of it all.
Gorgeous game. Yeah. What are you playing it on?
PC.
Okay. Very good. Well, for my part, I've been still playing through Indiana Jones and Great Circle, which is, it's the reason I actually went to an RTX card, because I was rolling with a 1080 Founders Edition for all these years because I didn't need anything at 1440, but it required an RTX. So I jumped in and did that. Oh, it's so good. Balatro too, it's ridiculous. But then Jeff Minter did a remake of iRobot, this classic Atari game that was one of the first polygonal games in the arcade. Incredible. And then Blueprints. Have you all played Blueprints or heard about this game?
No.
It is the most ridiculously amazing, awesome premise of solving a mystery like in this mansion, but you only have a certain amount of steps you can take through the mansion every day, and every room you go into, you have to place what the room is going to be that you are going into. So imagine like a roguelike deck builder where the deck that you're building is the floor plan of the house that you have to explore, and every day it changes. It's insane. I was talking to a colleague of ours. He's put 120 hours into the game so far, and he finished the main loop at like 60 hours. And he's still in there, like uncovering all of it. Blueprints is the name of it. It's going to rob all my time, I know. There's so many awesome games, but yeah, good selections all. And yeah, speaking of games, let's go ahead and jump into the development side of it. And let's, again, jump right into our subject matter. So we're talking, again, extending our conversation from the last episode, and this is about optimization for the life cycle of a game. So who wants to go ahead and jump in and start us on this conversation, how we can help our audience better understand how to optimize or use containers and optimize their game development life cycle?
Yeah, I can start us up. Maybe we could talk a little bit about GitOps and what it means.
Yeah.
So essentially, GitOps is engineering practice, as a workflow to be able to have your configuration in Git as the source of truth, and then being able to push that out to all your clusters. Say EKS is a particular one that it's used for. So it differentiates from infrastructure as code, as think of it as laying down the infrastructure and then being able to version out the configuration of that. So it's very useful when you want to scale a game, for instance, and you want to change maybe the replicas on your cluster, and you want to be able to audit and document that. You'll make the change to Git, and that gets propagated to different tools to your cluster. So that's essentially GitOps in a nutshell.
Yeah, and which is super important to have that single source of truth, because especially as more and more developers are working with remote teams, so making sure that everybody is kind of defaulting back to the same repository and everybody's versioning correct, using the same version, and make sure that stuff is in sync and not breaking, like super important, again, especially in a remote development environment, right?
Yeah, that's right. So essentially, instead of making changes in production and then not knowing exactly what happened, you make your changes in Git, and Git becomes the one source of truth. And then you can version out those changes throughout your cluster. So it's a nice way to keep everybody sane.
Right. Sane and make sure nothing breaks and people aren't right. Yeah, of course. Yeah. So talk about maybe what the key components of GitOps in a container workflow would look like.
Yeah, so you can use tools such as Argo CD and some of those open source tools. And essentially the way it works is that, let's say you have a cluster and you have some specific configuration for maybe your nodes and such, right? Anytime you need to make changes to that configuration, you will go ahead and check those changes into Git first. So maybe back in the day, people used to make changes in production, and then things would break and you don't know exactly how to roll it back. The advantage of this is that you can make a change in Git and then push out those changes through tools like Argo CD and such to your clusters, and then being able to roll back those changes. So if those changes for that configuration didn't work very well, then you can essentially go back to a configuration that worked much better for you. So,
did you say back in the day?
Back in the day for me, I guess.
Because we still see people using local repository stuff and then never checking correctly and constantly making tweaks and doing things that break that pipeline. So, as you're standing up your studio, as you're looking to go ahead and standardize on that single source of truth, really important to make sure that everybody's following the right procedure to go ahead and check in code, and make sure that that you're using those sources correctly, right?
Yeah, that's right. And then you can version those out. So essentially, everybody in the team always knows where things are at. Developers can check in application code, and then your operations team can actually make changes to your clusters and making changes to the configuration. So being able to audit and understanding where your configuration is. So there's never any surprises as to the state of your clusters, right? It's always in the one source of truth, that's Git.
And then on top of that, you can have a testing framework so that as you try to find out, having no surprises, as you just mentioned, using tools like what I've seen in customers like Locust is a really good one that can start helping test those workloads as part of that pipeline and have it automated as well. So that's an extension I've seen.
Very cool.
Yeah,
good.
Yeah, I was gonna say that's a good point. Kind of like your pipeline, it's like the bridge to get your application out there. But there are all these things that go along with it, like Daniel was saying, your quality gates, right?
Okay, so let's talk a bit about how you would go about setting this up, right? For somebody that may be new to figuring this out and why to do it in a container, talk a bit about. Can you guys lean in and talk a bit about what the procedures for setting this up? What are some of the other tools or options that people should be looking at? So can you walk us through quickly, like, okay, what are the steps to go ahead and kind of setting that up?
Yeah, sure. So first of all, you probably want to start something small. If you're just getting started using infrastructure as code, lay out all your foundation for your infrastructure, for your clusters, and also set up a pipeline like Daniel was saying, CI/CD pipeline, so you can actually deploy your application. You can use tools like Argo CD or Flux that are pretty popular for being able to actually do the GitOps. Once you deploy your applications, you can use Docker, obviously, for creating your containers and be able to deploy those. So there's quite a bit of stuff that maybe we can talk a little bit more about it, but that's what I would say. Just start small. Start with just maybe one application, deploy your cluster to infrastructure as code, get a pipeline going, add Argo CD to it, and get your configuration tweaked out, start testing that out. I wouldn't start necessarily, Argo CD and tools like these can be automated to essentially just pull your changes from Git and then deploy them to production. But I would probably start by going slow and pushing those changes manually until you get the hang of it and you understand the consequences of that. And then once you have your quality gates up, your testing, your CI/CD, your GitOps, then you can probably turn up the volume and then have it go automated. And the last thing I would say, also make sure you're testing your if you want to roll back. So you want to be able to understand that it's not just roll forward, but roll back, so that you can get to a state where things are working the way you want.
Okay, so basically you're slow walking this in, right? So you are doing these manual pushes to make sure that nothing breaks. And then something like Flux or Argo CD, these are tools that are used to kind of, they're synchronization agents, right? So they watch that Git repository, automatically apply any changes to your cluster, right? Ensures that your actual infrastructure always matches what's defined in your code, right?
Yeah, exactly. So they're pulling your Git repositories. Think of it like that. Always calling home, making sure everything is in check. If they detect any drift or there's any changes made to the production clusters without having gone through the Git workflow, then they'll automatically override that. So that's something to think about, especially if it's set to automatically make those changes. Which is where you want to get to. That's the goal, right? To be able to keep everything always coming out of the one source of truth, which is Git.
Yeah. So I do want to ask a question, since you've mentioned this several times, and it may be a term that not everybody's super familiar with. But when you talk about infrastructure as code, so what is the difference between infrastructure as code and GitOps?
Yeah, sure. So infrastructure as code, think of it as laying out the foundation. So if you were kind of creating like an airport, right? You have the infrastructure already set to be able to deploy the entire airport. And then you wouldn't make too many changes to that. You kind of have the airport operating. And then think of GitOps as having the actual planes operating every day. And those could change, come in and go, different planes, different flights, more of a configuration thing. So they're not really moving the actual airport, right, which is your infrastructure, but they're kind of moving the actual day-to-day things. Right. So the operations to be able to scale your clusters or things like that. That's how I think of it. So
yeah, you would generally like maintain separately, right? So like baseline infrastructure, like virtual private clouds, like networking for the clusters and anything, you're going to handle that in an IAC service like Terraform, right? And then once we're maintaining all of that, and it's the same thing, like you can version those Terraform scripts out. You can have a CI/CD process for deploying changes as well. And then we use like Flux, Argo CD to maintain like those Kubernetes clusters and make sure that we're maintaining, like, as you mentioned earlier, JP, like that desired state, and just constantly polling and just updating for changes to make sure everything kind of just stays up and working as it should.
Awesome.
Yeah.
Now, how about like in a multi-cluster setup? How does GitOps handle, again, a multi-cluster setup?
Yeah. So the way I see it handle, you still have your one source of truth, but since you can have tools like Argo CD and GitOps tools per cluster, they'll be pulling out from that one source of truth. So even if you have multiple clusters across multiple regions, you can organize those so they're pulling out that configuration from the same Git repository. So that makes it easier to manage, right?
And a lot of those configurations are supporting multiple regions, multiple setups all at once. So it is a single source of truth and no added complexity, despite having multiple clusters, as we alluded to. So
very cool. So whether it's a single cluster or multiple clusters, right? This is a way to go ahead and manage and make sure that you're provisioning code out correctly, it's versioned correctly, that it becomes a single source of truth across all of them, and can basically automate the entire management of that layer for you. Again, using tools like Flux or Argo CD, right?
Yeah, that's right. It helps you with that complexity to be able to keep things up to date, but also manage that complexity of having multiple clusters, especially across different regions.
Right. Different regions, different product cycles, different growth stages of the company, right? So you may be starting small, but the opportunity here is as you grow, as your development pipeline grows, as it becomes more complex, you still have a foundational layer that allows you to meet that complexity and not have anything break, right? So, because we know, right, the more complex it gets, the more places for people to go and store stuff, especially if people are spinning up containers, out of band on their own, right? By having that orchestration layer will help to keep all that stuff in check and help you manage an increasingly complex and growing development pipeline.
Yeah, and actually, since these tools are relatively platform agnostic, meaning whether you're using something like Kubernetes or regular containers or ECS, whichever orchestration platform, I think that's also a topic, that's very much of interest, as we're talking about how the GitOps process is going, what platforms should we be choosing? What are the differences between these platforms? That's also very early in the game development process in which these decisions are made. Maybe we could talk about as well.
Yeah. No, awesome. All right. So from a single source of truth, utilizing Git correctly, going from single container to multiple to again, to larger cluster scales as you go ahead and grow. That's one way that you can go ahead and maintain that growth curve by automating the orchestration of all of that, as the team has just discussed, and making sure that you're keeping everything in line, right? And people aren't breaking stuff as you go and you build. So, but let's talk about, all right, moving on from that, we talk about things like using containers for game launches. Why would a developer want to consider using containers for launching a game? Who wants to jump in and lead us on that conversation?
So I'll hop in on that one. Like one of the main benefits of using containers for like containerized game servers or like backend services is basically like you get environment consistency and like portability. So I can package up a backend service or a game server, and I can test it locally. Right, I can test it across a variety of like infrastructure, and because the nature of the container, right, I'm packaging all of the application dependencies into this known Git artifact. I can start spinning that stuff up across like infrastructure types, and kind of have this peace of mind that like, hey, that's going to spin up, right? As long as that hardware infrastructure, like whatever it is that I'm trying to spin that container up in, as long as it has the specific like hardware right? So like generally like CPU and memory availability, like it's going to be able to run like whatever in the container. So like that's like one of the chief like things is I'm able to just run this straight down the pipe from dev all the way to like an active production environment. And like, I'm just going to know it's going to work. A couple other things is like containers, like depending on the technology you're using, right? Because you can run containers on like GameLift, you can run it on EKS, ECS. We have a serverless option like called Fargate. You can even run containerized like Lambda functions. Is like you get this kind of breadth of like services that can all like independently scale for traffic spikes, right? So I can more closely like scale services to actual like players, like concurrent player count, right? Instead of needing to spin up like these really, really big fleets like ahead of time saying like, we might have this, I might be able to just set up for my baseline, because that can, all those different container technologies enable me to kind of like scale up automatically. I can start scaling like with like player traffic increases. So it kind of helps reduce costs, like helps reduce that overarching like technology overhead that we have going into that launch. And then I'm able to kind of just like scale to meet the demands like in the place. And then like another big reason is just costs, right? Like I named like 5, 6 different like AWS services that you can use containers with. And depending on whether it's a game server or a backend service, like putting it in ECS or EKS, like is really going to like help drive down costs. So I would love to hear like how you guys as customers are using containers like in that prep for game launches, because I have customers who have stuff like actively in production. I have startup customers who are driving right towards containers to get testing and dev infrastructure set up. So I kind of see it all over the place in startups.
Yeah, would love to hear, in general, what you see customers doing, how they're using this on AWS. So who wants to jump in?
Yeah, so I've seen customers, actually the customers I've interacted with use each of those, where I've seen Kubernetes, ECS, and GameLift. I've seen that at least for long running sessions, Lambda would be, not as much of a fit, but I've seen Lambda help in auxiliary asynchronous processes for sure, 100%. And the emphasis I've seen from customers is actually on the cost, in which it's another more granular measurement compared to an entire instance. You can have it within, subsections of an instance, in which when you have your bottom line and your running costs more directly tied in that extra granular level of measurement, in which it is each container size, it's mapped out to be cheaper and just more directly aligned in a marginal way to the actual traffic that you have. So for example, if you have large amounts of instances, the next instance that you spin up, that large one, is an entire bottom line you have to add, and an entire chunk that you have to fill up, and any like headroom that you're missing is lost, right? But containers is very flexible, as Adam mentioned, and a very good mechanism to make sure you're aligned with that cost. And that's what I've seen my customers emphasize, just as much as the development, the speed of development. But those two have been the biggest ones I've seen from customers.
How about you, Zach?
Yeah, some customers I've seen and worked with have gone the more of the containers route, more with Kubernetes, because they've seen open source projects like Agones and OpenMatch that they've wanted to adopt. So I have seen a bit of a trend with some customers going that direction.
JP, anything to add?
Yeah, so I was going to say the containers, the flexibility for developers, that's a plus, and obviously it's cost effective. You only use what you need, but I would say that's one of the things that I think developers really like, being able to say, this is my container, this will work in production the same way it works on my machine. Seal of approval.
Yeah. I mean, look, I think that, at the end of the day, from a game development perspective, sometimes they don't think about the back end as much as they think about that vertical slice of a game that they need to go ahead and get the art right, the environmentals right, because they're either out pitching for funding or those types of things. And what happens 9 times out of 10 is say, oh, well, I know that I'm band-aiding this, or I'm just using some sort of, patch here, and I'll just go back and fix it. And nobody ever goes back and fixes it, right? Because it's like, okay, it's just working. I don't even remember because nobody documented it correctly. So we're just going to continue to kick that can down the road until it comes time to deploy. And we've seen games that had kind of walked that same path, that get to deployment, they can't scale, they fall over, and the company goes out of business, right? Because they didn't have kind of a sanitized or a structured way of managing that infrastructure in the back end. So by making sure that you have that entire stack, right, that the games will run the same way across your dev, staging, and production environments, that you can package the server and those backends with all those dependencies into that container, allows you to have consistent deployment, right? Not only across your localized machines, but of course on the infrastructures you're deploying it as well. And it will help you to trap things like, bugs caused by environmental deficiencies and things of that nature. So get it into that container, and it provides portability. Look, I mean, the reality is that if you need to go ahead and lift that into a different region or a different geo where you may not have the same services available to you because it's containerized, it can be moved, right? This is kind of future-proofing in some ways the backend that you need to deploy on. So containers from the beginning, right? A really great way to think about compartmentalizing all of that backend infrastructure and those dependencies into that container, and then you can scale those out, right?
Yeah, exactly. So yeah, and when you think of containers, a lot of times you will see the actual shipping containers as images that depict it, and I think it's a good analogy, right? So it allows you to quickly move containers from one geographic area to another.
Yeah.
So, yeah.
I love that analogy as we had talked about when Daniel mentioned RuneScape and old Java. Back in my Sundays, they had done shipping data centers in shipping containers. And the question was, how do you get a data center to a place of emergency or things like that? Well, let's leverage common infrastructure. Let's make sure everything's compartmentalized. We can reproduce these things. We know how to create redundancies in these by going ahead and pairing them. So it's exactly the same type of way to think about it. Everything that you then have in that container, you can wrap up, you can duplicate, you can scale across different backends, and they should all operate the same way. And get into that practice early on. Don't wait until there is a problem on the back end or something like that you need to try to refactor, because as we said, nobody ever goes back to refactor. We just continue to Band-Aid, right, and build those things typically in the games industry. So great advice for our listeners. And then speaking of scaling, so let's talk a bit about scaling for traffic spikes. Who wants to go ahead and jump in and talk about why, again, this is important for dealing with those unexpected wonderful traffic spikes that we get because your players thought your game was awesome and now they're crushing the infrastructure? Who wants to jump in?
So the big thing is like containerized like backend services or like game servers like typically launch within seconds to minutes, right? It just depends on like your game, and then it just depends on like the backend service and what you built it on, right? So instead of like a traditional set where it's like, hey, I have to keep either racking and stacking servers in a data center, or I have to keep spinning up additional VMs, right? And I'm packing these into EC2 instances like manually. Like we kind of just take all that away from you and just say like, hey, where are the boundaries? Like once we start kind of getting into this zone, like when can we start spinning up like additional like infrastructure to handle those traffic spikes, right? So we're able to monitor in a very granular level like what's going on in the environment and then initiate like automated tasks to keep meeting that demand and that spike.
Yeah, and I would add that the spikes and also the tear down of the servers that you don't need, the capacity you don't need.
Right.
So essentially, you only use what you need, and you're not having to constantly get more capacity out. If you don't need the capacity, you simply amp it down.
Yep. Yeah, which is one of the benefits of not only operating on AWS, but a lot of the services or solutions that we provide, like GameLift servers, for example, that just allow you to go ahead and grab that node closest to where demand is, go ahead and spin that up, have a session play out and then have it wind down. So you're only paying for what you use, because we have seen too in the past that companies that try to use bare metal and colo and try to figure that scaling on their own, if you don't get that mix right from the beginning, especially in a hyper competitive market like it is today, that can be the death of a company, right? Because you over provisioned basically iron sitting out there not doing anything. And so this is, again, another way to avoid that. The way I always view it is our job at AWS is to help get that infrastructure out of the way so developers can focus on making better games, focus on the art side of this, and not have to become cloud practitioners or experts, right, in cloud to be able to utilize the incredible infrastructure that we have. That's our job, right, is to kind of obfuscate or abstract the complexity from the developer. And again, following these examples and this advice will help reduce that complexity, allow you to scale better, allow you to scale with fewer bugs, like all of the things that we've been talking about. So really, really cool. Really cool.
And there's actually, there's no doubt that the capability of the infrastructure hosted on AWS can scale to that amount, and the actual hardware and technology is there. Because things like GameLift achieving 100 million concurrently connected users, and just how we have such amazing launches available, not on just EKS, ECS, and our hosted containers platforms, but on GameLift as well with the recent Apex Legends migration. I think it's amazing, like that we can show you that we're able to support all of this technology, all of this user base, but it's just a matter of reducing your complexity on orchestrating all of that, not really just can you actually host that amount of players.
Yeah, and customers can very easily, well, I'll say easily, verify those claims just by doing load testing, right? Which you should be doing anyways prior to any major launch. You should be load testing both your game servers and your backend. And one of the things that will enable you to do is see how quickly you can scale. Right. And they say, hey, we just did a load test for 100,000 users, right? We had enough infrastructure set up to cover 70% of that, right? So we needed to launch an additional game server, additional game servers that can meet that, extra 30,000 players that are logging in. Okay, well, how long did it take us to spin up that extra 30K CCU, in game servers or backend infrastructure, right? So load testing is great to kind of track that behavior of, hey, how does my containerized backend service or game server respond in these instances, right? And you can also containerize your load testing solutions too, right? So you can always count on your load testing solution scaling at that point. So there's kind of just net benefits all around to this technology in this arena.
And I'm seeing my customers scale up to 1 million concurrent users in their load tests. And just as you mentioned it, Adam, the best and easiest way as well to do this is to reach out to your AWS account team and utilize your tools and reach out proactively, because nothing should be a surprise. And then you could load test and make sure that you're at least set up in your configurations to handle that level of scale.
Yeah, and we have some basic guidance available for game studios with load testing, right? Just saying hey, here's a quick solutions guidance. It's going to spin up an open source load testing solution called Locus. It's going to spin that up on EKS and in a serverless fashion with Fargate. And at that point, your load testing infrastructure is set, and you just need to focus on scripting at that point. What kind of test are we running? I'm going to build that script out. I'm going to test that out, and you're ready to kind of rock and roll at that point.
Yeah, reduce your time to even set up the load testing.
Which,
right.
Yeah, that's awesome.
I would add that, like Chris was saying, managing that complexity, we have these new innovations like EKS auto mode and such that take away the need for you to be able to upgrade constantly the version of Kubernetes and things like that, that just make it easier to focus on your game, focus on your customers.
Yeah. I mean, look, what we're talking about, the advantages of containers and how you can utilize them to optimize, to create efficiencies, to reduce cost. But are containers right for all conditions, right? So when may containers not be the right choice for a developer? Who wants to jump in there? Zach, we haven't heard very much from you on this round, so why don't you jump in and talk a bit about that too?
Yeah, I could talk a bit. So containers in general, I think they solve a lot of problems, and they're like, we've gone over all of the benefits and everything. Some situations where I've seen people say, hey, like containers are great. I see the benefits, but I'm not going to make that decision or to go that route. Some situations I've seen that is one, if it like legacy applications, they've already built things up for like in a VM way, and it's just too hard for them to change it over and to modernize it. So I've seen that. Or if they're like migrating from one location to another, again, they're like, we want to do this fast. We don't want to refactor it into a container format. And then also, I haven't dive too deep into this, so I am curious to see if anyone else has this. I've heard from a few people that like on the networking side with containers, if you're having a very fast like first person shooter game server that needs high performance networking, that containers adds a bit of latency to that experience. And so they've decided to not go that route because of that latency aspect. I don't know too much about it, and I'm open to hear if anyone else has.
So anytime I've seen customers like have like a launch on a container platform, the general like overhead latency, like from the container wrapper itself, like what I've seen is pretty negligible. It really kind of comes down to like what is the experience you're trying to offer. Like, is it like an ultra low latency? Like I'm trying to have sub 10 millisecond latency for all my players. Because at that point, it's not so much I need to worry about the overhead of like the game server or the container itself, more as like, hey, where do I need to place that container? Right. So if like I'm doing a tournament and I know I'm doing like East Coast, West Coast, then maybe like deploying into like a Dallas local zone in a service, right, is going to offer that. There's like some additional like services and networking things we can do on top of that. But from what I've seen, like outside of like the like that specific use case, most customers are okay with it. Right? Like if you're trying to just kind of maintain like sub 50, sub 30 milliseconds, I don't see customers complaining about like the overhead specifically about a container. It might be like the orchestration service itself is doing something specific in the networking. They might need a little bit more control over that. But from my customers, I haven't heard anything. JP Daniel, like what have you seen from like bigger like enterprises?
I've seen customers interested in the Cilium service mesh for network performance across like at least EKS workloads. Apparently it uses like some sort of kernel technology, extended like Berkeley packet filter. It lets you have some sort of dynamic networking logic and other kind of things like security or other things, even on the Linux kernel level. And so it's like really deep networking, kind of high performance networking optimization options on EKS that customers have been interested in to help address the point that Zach brought up.
Yeah, the kind of same thing for me. Essentially, it's all about trade-offs, right? So if your game needs certain things, obviously, it's a case-by-case basis. So,
right, and that isn't. I think that's not specific to containers. That's with any technology that you're going to use to be playing online games, right? So you have some games that are going to be more forgiving from a latency perspective. You have others that will give you no leeway at all, right? And so players then have to work around those latencies. And I think all the way back to like rocket jumping in Quake and stuff like that, right? Where you're exploiting latency for an advantage, right? Fortunately, we don't really have that to deal with anymore. But yeah, it's not just about getting those efficiencies inside of the container and then being able to understand that you cannot replicate it, but where you're replicating, where are those requests coming in from? How close can you get to those players, and what part of the edge, right, do those exist? But I think that one of the cool things that we're talking about here, right, is that containers give the ability to get everything into one spot, kind of figure out the best way to optimize for that. And once it works, now you can just replicate that same efficient stack anywhere that you need to, right? So you don't have to go, all right, let me figure what we did here in this one environment, and now I have to figure out how we did all that, get all the same bits together to go ahead and make it work in the same fashion here. Inevitably, something breaks between them. So it lets you create that common infrastructure, common framework that you can then go make it portable and then move it right through infrastructure. So yes, it depends on the type of game that you're playing and where your players are.
Yeah, and I'll leave like one last point for this. like sometimes if you are creating a unique enough experience, it might not make sense to use that, right?
Mm-hmm.
Like we have a very unique, like never before created game. We're running on like a custom in-house built engine, right? And sometimes like it's okay to go the VM route, right? But what we see large amount of customers doing is solidifying behind this technology and kind of driving it forward. So there may be some instances of that, but for most customers, especially, you know, if they're using most of the standard like engine technologies and stuff we see like today, like all that stuff is built for containers and should work fine for it.
Okay. Awesome. Well, since you brought it up when you were talking about VM, let's go ahead and talk now. Let's shift gears a little bit and talk a bit about emulation, open source software, and best practices on EKS. So, Zach, why don't you go ahead and talk to us a bit about simulation software x86 on ARM game servers? I mean, and talk about why that is important.
Yeah, for sure. So at AWS, I've been working with a few people on running some experiments to see how we can help customers save money and so on. And one of the options we've been exploring is utilizing this emulation software called FEX-EMU, FEX-EMU, which is an open source emulator that's designed to try and be like as fast as possible, specifically for emulating games and game servers. So we've been exploring that, and the whole idea is that you'll give it an x86 binary that runs on that kind of architecture chip, and then it'll do an emulation so that you can then run that x86 binary on top of an ARM-based CPU.
Okay.
Yeah, so we've been looking into that, and kind of the main benefit or goal of this is basically, let's say you're a company, and you have a bunch of games, right? And then maybe one of those games you built a decade or so ago, and it has a nice community around it, and you want to keep the lights on, like support the community and all, but it's not like generating too much revenue for you. And so the idea is like, what if you could basically like take that kind of those game servers, and then you can decrease the cost of them by running them on some kind of ARM chip, such as Amazon's Graviton processors, while still maintaining good performance. So you can decrease your costing, still keep the lights on for those games. So that's kind of something we're looking into, and we're hoping that we can. And we've been experimenting with like taking that emulation software and then putting it inside of a container image, so that people can then get that container image and then build on, use that as the base image, and then build on top of it with their game files. So that's kind of what we've been looking into.
I love that. One of the, so like I try and push customers to ARM as much as I can, right? Like, hey, if that's workload on ARM, like it can run on ARM, like do it, right? You like Graviton instances, like we generally see like 2x the performance compared to like x86, and then substantial like lowering cost. But there's always, just from like the chief blocker I see from my customers, is like there's always like a physics library, right? That was like built for like x86 architectures, right? And like you don't have the physics engine's not working properly on it, and then nothing in the game works right? So something like that would be like a game changer for a lot of like my customers. I think a lot of games customers like in general. But like if you can architect your like core backend services, game server logic, like for ARM, like it's a net benefit all around.
Exactly. So it sounds like if your game already supports containers and it's x86, it can actually probably run on something like an ARM architecture using this container architecture. Is that right?
That's the idea. However, the emulation software, it's still like in development in some aspects, and so it's not like a foolproof 100% like accuracy translation of taking x86, like processes and converting it for like the ARM architecture. So there's still some things to work out, and things are still getting fine tuned. But we are experimenting with that.
That sounds cool. So our favorite games may never die then.
That'd be cool. Or they'd be cheaper to keep around, right? So you wouldn't have some old game servers like the Star Wars Battlefront 2 game servers going down or something.
That's right.
I mean, and so, we are moving into this really amazing era of game development where we're seeing things like, where we're seeing, I think, emulation hit the consumer in a more direct way than before, like with Steam Deck, right? So running Proton, right? So that way you get Windows games running on top of a Linux-based device. And that's becoming more normalized now, right? Same thing here, looking at how we go ahead and have an emulation layer that allows you to go ahead and run on an infrastructure that costs significantly less with equivalent performance, and drastically reduced energy costs as well. Like with like Graviton, means that we now, as you said, are able to get these games running on newer architectures that are being left behind are no longer the limiting factor there. So you can extend the life of your game, extend the life of an audience, reach a new audience at a later date, because you're going to be able to move that game to these different architectures, different types of systems, different types of endpoints as well, because of the current environment for emulation, right? It's pretty awesome. Not to mention, if you need to go run some stuff server side and stream it out, we have things like GameLift Streams that we just launched too, that can go and help you reach an entire audience that may have, anemic or underpowered devices, but then can go ahead and play these, these render crushing games on the back end. So yes, emulation layer, containers, getting more people to play across more platforms globally is awesome. And that's where we at AWS really lean into helping game developers to achieve those efficiencies and that reach from server side all the way out to the client. All right.
Yeah, and I could talk a bit more about like best practices and all in terms of with containers if you'd like.
That was my very next question.
Okay, nice. Sweet. Yeah. So so some things, right, that I often tell customers with containers and all is definitely like right, like, so you have best practices around the technology, but also you need really good practices around like the people themselves and in terms of how you're going to manage it and who has access to what. And JP talked a bit about that with GitOps, right? About like how we can take care of that. And then you need to like kind of make sure that you have a plan around who's doing what, who has permission for what with GitOps and in terms of like what resources and all. So I think really like having that kind of fleshed out is really important. And then also on the technology side, making sure that like your observability plan is really set, because with containers, there are so many like you have all the container processes going, and then if you don't really like filter down the outputs of these containers, then you can get like excessive amounts of logs. And so I really recommend people kind of trying to like filter down what they need coming from logs in the containers, so that they don't have too much that they're trying to sift through. So that's another thing that I typically recommend people do.
Awesome. Who else wants to weigh in on this incredibly important topic?
One of my things I tell customers, like if they can run like backend services like on like serverless platforms like Fargate inside of EKS, to do that, because that's just another layer of management like out of there at that point, right? At that point, I can just focus on like, hey, here's my container. I'm going to launch multiple copies of this in Fargate, and every container just needs like a quarter cut of a CPU and like half a gig of memory, right? And then the service just goes and starts deploying that stuff, right? So if your backend requirements like aren't like super like latency intensive, anything like that, like run stuff in serverless. It's just one less thing to worry about for you, and then you can start scaling those services automatically, like during big traffic spikes without really having to think about it. So serverless whenever you can. We'll love that stuff.
Yeah, can I chime in here a bit? So I've actually had customers who have had like tried to run Fargate 24/7, and it just eats up the cost like crazy. It just like skyrockets. And so I've actually seen like a really good cost benefit and operational overhead benefit for people who have like spiky workloads with Fargate servers. Yeah, for running servers on Fargate. So I just wanted to throw that in there. That like the spikiness is really good for Fargate.
And one thing that's really good if you can potentially utilize GameLift is one of the features within GameLift that lets GameLift actually kind of calculate what the actual odds of having a Spot used with compared to the downtime. If those of you who may not know about Spot, Spot is basically going to have potential like cutoff when a certain price for the instance that's usually on demand is out of commission. So they usually have on demand instances, and when they're not being used, they're available for being used by users of Spot, in which when they're being reclaimed, they're getting reprioritized for an actual on demand user, but you have a lot of low cost access to these unused instances. And when we see customers utilize Spot, we see them used for either game modes that are allowing for these disruptions, or maybe even training modes and things like that. But I've actually seen customers utilize, especially when it worked for their own game, using Spot for their actual main game use. I actually have a customer that uses 100% Spot, and we're actually working on a case study to release on that. And my point about all this is that what GameLift is actually able to utilize like an algorithm under the hood to say, hey, you're not really going to get as much interruption from Spot if it's being negotiated at this price. You can actually find a system that already calculates for you having Spot use as much as possible without having the downtime. And that's a really good capability you can use as well for cost reduction with containers on GameLift now that that's available.
Yeah, you can use that. So that's Fleet IQ inside of GameLift. And so you can actually use that on Kubernetes too. We had a project that we open source. It's Agones and Fleet IQ on EKS. It needs an update, but I know customers who are using that to run like GameLift controlled Spot instances in their EKS clusters, and it works really well, and it's super cost effective.
Well, I mean, since you mentioned to open source, when should customers consider open source software versus proprietary server hosting options like GameLift?
If it's removing like the undifferentiated heavy lifting from the workload, and it's easier for you to manage, and like I would start moving towards like open source stuff. Like Agones is an open source like abstraction layer for Kubernetes clusters, and it basically kind of like hones down like the Kubernetes capabilities into just like very simple like game terms. So it's like game servers. It does things like automatic like UDP port mapping for you, like so you don't have to build that logic layer out. So when it's stuff that's open source that you don't want to build, right? Like go ahead, test it out and use it. And if it works well for your game, like there shouldn't be a problem using it in production.
There's also a general gravitation of open source to be flexible across multiple platforms and technologies, and then also not suscepting you to vendor lock. And so it's really good if you want to just keep a good flexible and honestly it's completely open, hence open and open source for you to be able to look at the changes and contribute to the changes, and it's all transparent in that sense.
Yeah.
No,
absolutely. Yeah. I mean, open source has some incredible benefits, and I think those benefits become compounded when we are able to start running those solutions on top of an abstraction layer, like an emulation layer that allows you to actually migrate those things. So it's giving more reach to open source software. And to your point, you're able to actually look under the hood, make changes, and contribute them back to the community to make everybody better. Rising tide lifts all boats. Love that about open source. So yes. All right, but let me ask you a question then. My panel of experts here. So how should someone without any containers or Kubernetes experience get started?
I mean, you can always just start by like creating Docker images and deploying stuff in local dev machines first, just to get familiar with containerization, like how things on Docker runs, right? When you're ready to kind of like dip your foot into deploying services like at a small scale for testing and everything, I love the Elastic Container Service. Like this is our like Docker service, basically. It's a managed service that just focuses on like running the containers. You can run it like with managed nodes, you can run it in a serverless fashion, and it's a lot easier to consume and get started with upfront than like managing an entire Kubernetes cluster or multiple clusters. So for customers with not a lot of experience, it's kind of generally where I kind of send them. And then as they start like developing that muscle memory for like how this tech works and how they need to set stuff up, that's when I'll start like introducing like more advanced topics. Like, hey, here's Kubernetes, which is a whole different like control plane setup. And I'll bring in experts like Zach at that point to like give them a deeper dive on the technology. But ECS, like that's always like local dev ECS is always a great place to start.
Yeah, and I would add that to get started with definitely something small. If you're a developer and you haven't touched containers before, you can easily just write a quick HTML5 game or something like that, very simple, and then create a container for it. And we have tools like CDK and such that can help you with that infrastructure, and then just get it out there into ECS or EKS, whatever you want, and just kind of get it to work and get it to render. That's a pretty big victory. Once you see that, then you can get ahead and get some more complicated stuff. But I would say just start small. If you're just getting started, don't be afraid to jump in and dive deep. We have plenty of tools out there that can help you.
My take is to lead. Oh, go ahead, Adam.
So the only thing I was going to say, Daniel, is we also have a lot of public training and workshops available around all of our container services. So you can go to the EKS workshop, you can go to the ECS workshop for free online and start like messing around with this, like that stuff there too.
Yeah, we're going to include links to those resources in the show notes, right? So anyone that's listening to this on YouTube or whatever, you can go and check out the show notes and there'll be links to some of those resources there. Daniel, you were going to say?
Yeah, and we presented a lot of information, right? And at the end of the day, we're here as your AWS account team to help you navigate these. That it's a sea of information and options, and the question of which platform should I use and which, how should I get started? Where are these resources? The notes are there, the links are there, but reach out to your AWS account team. We aren't just, we are here to help guide you through what is the right platform to use and what the right technologies are. Adam gave a great example of how he's practically actually doing the practice of, working with the customer and finding out these right solutions and guiding them through a path. And so that's what I would recommend customers start, just like what JP said, start with a project, but reach out to your account team and get that like extra hand of help.
Okay. Now, I think that is a great way to go ahead and end this episode, optimizing containers for game lifecycle. I want to thank my co-hosts today, Adam Hatfield, JP Velasco, Daniel Lee, and Zach Sterling. And once again, here on Boss Level, we try to go ahead and simplify and demystify how to most effectively use AWS technologies and offerings. Make sure you check out previous episodes as well. Make sure you check the show notes for links to all of the technologies and services that we discussed on the show today. And again, I want to thank my panel of experts here for joining me today on this episode of Boss Level. Thanks, gang, and have a great rest of your day.